now that we've checked that our per month drinking items are reliable, we will check that our alcohol expectancies items are reliable. So we can just exit out of this if we want. So now we're going to do all 10 of the alcohol expectancy items. So we want to go again up to reliability. That's the test that we want to run. Again, unidimensional reliability. And we will move all of the alcohol expectancy items over. If you want to select a lot of items at one time, you can hold down Shift and just push the down arrow on your keyboard, and it will highlight all of those together, and then you can move them over to the variables box. You can still do it one at a time, that's fine, but to do it quicker, you can just select them all at one time. So again, we don't want McDonald's W, so we'll click on the analysis drop-down box, and we'll deselect McDonald's W and select Cronbox Alpha. So we have a Cronbox Alpha of 0.93. Again, so 0.7 is acceptable, 0.8 is good, and 0.9 or higher is excellent. So this is an excellent scale or an excellent measure. It exhibits excellent item reliability. So all of the items are related to each other. This is what we want. So both of our measures are good. Before I go on to the final correlation analysis, which is what we're looking for, I want to show you what Cronbox Alpha is doing and why we use the Cronbox Alpha instead of getting a correlation for each of the items. So what I want you to do is we're going to correlate all 10 of these items with one another. So to do that, to run a correlation, you want the regression menu. We're going to do a classical correlation. So we want to correlate all of our alcohol expectancy items. So we're going to select them from this left box, all 10 of them, and we'll move them over to the variables box. The correlation coefficient that we're going to use in this class is Pearson's R. How we interpret Pearson's R is 0.1 is a weak effect, 0.3 is a moderate effect, and 0.5 or higher is a strong effect. So if anything that reveals a Pearson's R above 0.5 means that those two variables are strongly correlated with one another. We also need to check whether or not they are significant, because if they're not significant, then they're not correlated. So we want to flag significant correlations here. And then this is our correlation matrix. So this is all of the items and their correlations with one another. So I'm going to make this bigger by moving the input options over by clicking this arrow. Okay, so this kind of looks like a mess, but you get used to looking at it. So let's go ahead and just look at it column by column. So this first column is the item alcohol expectancy 1. So remember, our participants answered 10 questions about how they perceive the expectations after drinking alcohol. So the first item is, this is the correlation with the second item. So the Pearson's R, the Pearson's R for item 1 and item 2 is 0.577. It is significant, so these asterisks, as we flagged them to show if they were significant, we can also see that the p-value is less than 0.001. So remember from statistics, p-values less than 0.05 or less than zero point 0.1 or less than, less than 0.01 or less than 0.001 are significant. In this case, if it being less than 0.001, that means that it falls within the 99% confidence interval. So with this being significant and the Pearson's R being at 0.577, we know that they are significantly correlated, and that is a strong positive correlation because it's above 0.5 and the sign is positive. So that means that all of the items positively correlated with all of the items from alcohol expectancies too. So let's see the items correlated between 1 and 3. That's at 0.588. So it is significant. And again, it's a strong correlation. What that means is participants who answered, let's say, high on the first question also answered high on the third question. That's what we're saying when we are saying that they're correlated with one another. Item 1 was also strongly correlated with item 4. Item 1 was also strongly correlated with item 5. Item 6, this rounds up to 0.5, so we can go ahead and say that that's strong. This rounds up to 0.5, so we can go ahead and say that's strong. 0.57, that's a strong correlation, and 0.52, that's a strong correlation. So we can see that all of these items are strongly correlated with item 1. We can do the same thing with item 2. We can see that item 2 is strongly correlated with all of the other items as well, and so on and so forth. If we went to look at all of these, we would see that each of these items are strongly correlated with one another. So what Cronbach's alpha is doing is it's analyzing all of these intercorrelations together. So rather than looking at each item by item, Cronbach's alpha is correlating all of those items for you and giving you a different value to interpret. We interpret it as 0.7, 0.8, and 0.9 being reliable, with 0.7 being acceptable, 0.8 being good, and 0.9 being excellent. So this is what Cronbach's alpha is doing in the background for you. It saves you time. Okay, so I will open this back up. Okay, so now what we're going to do is see whether our two variables are correlated with one another. That's our research question. Do alcohol expectancies relate to higher behaviors of drinking?